Welcome to the second episode of this series where we're recreating the classic game of columns. Today we have two objectives. We want to add color to the gems and we want to make them fall down. So let's see what we have so far. So far all we have is a play field and we can draw what you might call a gem with a bit of imagination. Let's start with adding color first. So to do that, what I'll do is, it might be even nicer to do that in game scene. So let's create an extension to our gems and we'll create a variable called color that will return an skColor, and this will just take every type of gem and return a color. Okay, so now we can get a color value from our gem, and that also means that we can have our gem shape here, take a fill color and use gem.color. And that's the value, because that's the actual gem. So let's see if this makes a difference. So now we can at least differentiate between the various gems. We'll use proper sprites at a later date, but this is enough for now to at least demonstrate the way the game works. So that's color. Second, I want to work on gems falling down, because that is such an important part of the actual gameplay. So to do that, I'm first going to write a test, because this is all model related code. So I'll create a new file called board tests, and this requires test, and this also requires importing our call tutorial. And then we create a final class board tests that inherits from test case, and the first test we'll create is gems fall down when there's space below, so there's place to fill, and update is called. So we'll take a board, then we'll add a gem to the board. I only have one gem for now. So we'll create one at a position, we'll give it a color, then we will assert that the position below this gem is empty, so that's a nil value. So we'll take our board and look at 3, 4 and assert that this is nil. Then we will update the board. So we'll create an updated version of the board. And now we can assert two things. Well, first off, the position of the current position of the gem. So the 3, 5 position where it was instantiated should now be nil. And the one below that was nil, so this one again, should now be a green gem. But we don't have an update function yet, so let's quickly create a stub so we can compile. So this should return a new board, and so for now we'll return ourselves. Let's build and run tests. Well, the test we currently have. Oh, and I should definitely disable these UI tests because we're not using them and they always take a very long time to run. So let's go back to this one. Okay, so the test fails because, well, gems aren't falling down yet. Yeah, these are all the UI tests that are still running, so I'll let them finish for a time because but it takes so long. Okay. Okay, but these should not run again now. Okay, now the tests go very fast because it's just these program-related tests that are running. So test fail, we should implement some falling gems behavior. So what we can do is we can create an updated board as a copy of ourselves, and that's also the one that we return. But here what we'll do is we'll go through each gem and we will check if is there space below the gem. So if gem.key plus down, we'll create a down vector in a bit. If this one is nil, so then it's empty. And then we do updated board gem.key we remove the value for key gem.key and the updated board gem.key plus down. This one will be our gems value, and we should define .down in the vector. So we'll create an extension for basic values. We can't add vectors yet, so we need to implement some vector mathematics. Okay, so let's run the test again. And the test still fails. Oh, because we should check the updated boards. And now the test passes. So let's see if we can also see this in our game. So let's go into our game scene and let's say we create an update method and the board is the board.update and then we draw the board. Let's run. Okay, so can't see anything. Where are all our gems? Well, they're falling down way too fast, so we can't see them. So we need to implement a way of slowing down the update process, and we can do so by making sure we update once every certain time. So let's say we have to do that, we need a last update time, and we need an update delay remaining, and we need to determine our update interval. For instance, every half second. So 2 times per second we want to do an update. So to do that, first we need to determine the delta time, and that will be the current time minus the last update time. Then we need to set the last update time to the current time, and then we will take the delta time from the update delay remaining, and if the update delay remaining is less than or equal to 0, then we do the board update, and we set the update delay to the update interval. Let's see if this helps. So let's build and run. So okay, so look, they're falling, and however they keep falling through the bottom, and that's because we still miss a test, and that's 4. Let's see. We need a test where a gem does not fall below the bottom. So we'll take a board, we'll create a new gem. It can be green. Then we update the board. Then we assert that our updated board at the 0 position has indeed a green gem, and the one below is nil. So we start out in the bottom row, and we check that we remain in the bottom row. So let's run this test. And the test fails. But we can fix this by checking if the gem's y value is bigger than 0. So let's run the test again. Okay, it passed. Let's run our game again. So this one keeps staying here, this one keeps falling down. And let's see what happens if we have, let's add another gem that can fall off on the other one. So we'll create a blue one. Let's build and run. So we have the blue one, and it falls until it can't fall any further. Cool, right? So I think this is the basic falling behavior implemented. I think next time let's add the actual sprites into the game. Better get that over, and then we'll go from there. Thanks for watching, and have a good day.